On July 1st, 2025, a telescope in Chile saw a speck moving across the sky. It was small, faint, the kind of thing that gets reported to the Minor Planet Center every week by automated survey systems scanning for asteroids and comets. It received a designation. Astronomers checked its orbit, and within hours, the phones of planetary scientists around the world were ringing because the orbit was wrong. Not wrong in the sense of a calculation error. Wrong in the sense that no object with that trajectory could have come from our solar system. The eccentricity, the number that describes how elliptical or hyperbolic an orbit is, where anything above 1.0 means the object is not gravitationally bound to the Sun, was 6.139. For reference, the most hyperbolic solar system comet ever previously recorded had an eccentricity barely above 1. This object's eccentricity was 6 times higher. It was not passing through the solar system on a wide arc. It was screaming through it, arriving from interstellar space at 57.7 kilometers per second, faster than either of the two confirmed interstellar objects that preceded it, faster than Oumuamua, faster than Borisov, a bullet from another star system fired at unknown speed from an unknown origin, passing through the one patch of space where humanity happened to be watching. They called it 3I Atlas, the third confirmed interstellar object to visit our solar system. And what scientists found when they looked at it closely broke every assumption they had built from the first two. The NASA-funded Atlas telescope first reported observations of Comet 3I Atlas on July 1, 2025. The fast-moving comet, which originated outside our solar system around a different star, was discovered as a tiny speck moving across the vastness of space. Scientists determined that 3I Atlas was interstellar because of its high velocity and its trajectory. The first anomaly appeared almost immediately. When astronomers began measuring how 3I Atlas was moving as it fell toward the Sun, they noticed it was not moving exactly the way gravity dictated. It was accelerating slightly. Not toward the Sun, not away from the Sun, but sideways, a non-gravitational acceleration with a substantial sideways component. Comets do this. The jets of gas and dust that outgas when a comet's ice heats up near the Sun can push a comet in unexpected directions. But the sideways component of 3I Atlas's non-gravitational acceleration was unusually large, and the jets causing it were unusually structured. Processing of 40 Hubble Space Telescope images from November 2025 to February 2026 by the Larsen-Sechenina filter, which removes the circularly symmetric glow around the nucleus, reveals a system of 3 mini-jets which are symmetrically separated by 120 degrees from each other. The non-gravitational acceleration of 3I Atlas was not directed away from the Sun, but had a substantial sideways component. 3 jets, separated by exactly 120 degrees. Perfect symmetry. In nature, perfect symmetry in 3 equally spaced jets has no obvious physical explanation from standard comet outgassing models. Ice pockets on a rotating comet might produce jets, but to produce 3 jets evenly spaced at precisely 120 degrees from each other, those ice pockets would need to be arranged with a precision that geology and ice formation processes do not easily explain. Harvard astronomer Avi Loeb, who has been cataloging the anomalies since discovery, asks the question that the data raises, but that most scientists decline to answer. Are these symmetric jets the sublimation of pockets of ice on a rock, or are they technological thrusters? The second anomaly was in the water, not the presence of water. That was expected for a comet. The type of water. Researchers discovered that 3I Atlas contains an exceptionally high amount of deuterium-rich water. The amount of deuterium with respect to ordinary hydrogen in water is higher than anything we've seen before in other planetary systems and planetary comets. The deuterium ratio in the comet was about 30 times higher than what has been measured in comets from our solar system, and roughly 40 times higher than the ratio found in Earth's oceans. 30 times. The ratio of heavy water to ordinary water in 3I Atlas is 30 times higher than in any comet from our own solar system, 40 times higher than in Earth's oceans. Deuterium, the heavy isotope of hydrogen with an extra neutron in its nucleus, is produced in specific conditions that reflect the temperature and radiation environment where water ice forms. The deuterium ratio in solar system comets has been measured across dozens of objects and falls within a range that reflects the conditions of our solar system's formation approximately 4.6 billion years ago. The deuterium ratio in 3I Atlas is not within that range. It is not even close to that range. It is a signature of conditions profoundly different from anything in our solar system. Formation in a region of space colder, older, or more radiation processed than anything in our cosmic neighborhood. Based on its trajectory, astronomers suspect that 3I Atlas could be the oldest comet ever observed. The oldest comet ever observed. Some researchers calculate that the trajectory 3I Atlas arrived on is consistent with it having spent billions of years traveling through interstellar space, potentially more billions than the solar system itself has existed. a comet from a star that may no longer be burning, carrying water that formed under conditions that predate the sun, passing through a solar system whose inhabitants happened to build telescopes just in time to watch it go by. The third anomaly was structural. When Hubble's Wide Field Camera 3 imaged 3I Atlas in November 2025, it captured the coma, the cloud of gas and dust that surrounds the nucleus as it heats up, and found it had an unusual blue color. Blue comets are not unknown, but the specific shade and intensity of 3I Atlas's coma was distinct from the comets of our solar system in ways that spectroscopic analysis is still being processed to explain. More strikingly, there was an anti-tail, a jet extending in the direction opposite to what standard comet physics predicts. Solar wind and radiation pressure push cometary material away from the sun, producing the tail that points away. An anti-tail pointing toward the sun can result from specific geometric viewing angles or from unusually large dust particles. The anti-tail of 3I Atlas was prominent enough that Loeb lists it among the 22 anomalies he documented in March 2026, after the object had passed closest to Earth and was heading back out toward Jupiter. When 3I Atlas was discovered in July 2025, I gave it a rank of 4 on the Loeb classification scale of interstellar objects, where 0 means a natural comet and 10 means alien technology. It is the responsibility of scientists and NASA officials to acknowledge the existence of unexplained puzzles, rather than display the arrogance of expertise while ignoring them. A rank of 4. Not 0, which would mean confidently natural. Not 10, which would mean confidently artificial. 4. In a middle territory of genuine uncertainty, with 22 specific anomalies that Loeb documents, of which most have plausible natural explanations, and several do not have any explanation that current physics comfortably provides. The mainstream scientific consensus is firm. 3I Atlas is a comet. Most likely, 3I Atlas is a comet. It has an icy nucleus, produces gas and dust, and grows a coma and tail. Textbook comet behavior. The ESA, NASA, and the scientific community that has studied it most carefully all describe it as an interstellar comet. Extraordinary in origin, extraordinary in the data it provides about another star system, but consistent with natural processes. A comet unlike any from our solar system, yes. A comet with unusual chemistry and unusual jet structure, yes, but a comet. The fourth anomaly was in the X-rays. In late November and early December 2025, 2 X-ray space telescopes, XRISM and XMM Newton, turned their instruments toward 3I Atlas and found something that had never been seen before in any interstellar object. X-ray telescopes XRISM and XMM Newton observed the comet, revealing a diffuse X-ray glow around the comet nucleus. This makes 3I Atlas the first interstellar comet to have been observed in X-ray light. X-ray emission from comets is known. Solar system comets produce X-rays when highly charged solar wind ions capture electrons from the comet's neutral gas. But the X-ray glow of 3I Atlas was diffuse in a way that researchers are still analyzing. The X-ray signature of an interstellar comet, arriving from a different stellar environment entirely with different composition and different history, cannot be interpreted through the same models developed for solar system comets. The data exists. The interpretation is incomplete. And 3I Atlas is now receding beyond Jupiter, heading out of the solar system on a trajectory symmetric to its arrival, carrying its secrets back into interstellar space. The fifth anomaly, and perhaps the most philosophically significant, is the mass budget. When scientists calculate how much gas and dust a comet should be losing as it heats up near the sun, they compare that against how much brightening is observed. For solar system comets, these numbers match reasonably well. For 3I Atlas, the amount of material being released appears inconsistent with the size of the nucleus estimated from Hubble's observations. Either the nucleus is larger than it appears, or the material is being released in a way that the standard sublimation models do not capture, or there is something about the composition or structure of the nucleus that does not match what a comet from our solar system would look like. The mass budget discrepancy is one of the anomalies that Loeb specifically calls out as requiring physical explanation, rather than being dismissible as a coincidence or a measurement artifact. Now understand why this object matters so much beyond the anomaly list. Because the scientific value of 3I Atlas is not primarily in the mystery, it is in the window it opens. Interstellar comets are true outsiders, carrying clues about the formation of worlds far beyond our own. Every planet, moon, asteroid, comet, and life form in our solar system share a common origin, but interstellar comets are absolutely foreign. Absolutely foreign. 3I Atlas did not form in the same primordial disk of gas and dust that formed the Sun, the Earth, the Moon, Jupiter, and every other object in our solar system. It formed somewhere else. around a different star, in a different chemical environment, at a different time, under conditions that left their signature in the 30 times elevated deuterium ratio and the strange blue coma and the X-ray glow. When scientists analyze its chemistry, they are not reading the history of our solar system. They are reading the history of another one. And getting a sample, however brief and however distant, of what matter from a different stellar neighborhood looks like, how it formed, what conditions prevailed when it was made. The deuterium ratio alone is worth dwelling on. The specific amount of heavy water in a comet is a thermometer for the conditions where the ice formed. Low deuterium means the ice formed in relatively warm regions, close to a star. High deuterium means the ice formed in cold, dark, radiation-shielded regions of a molecular cloud. The extreme deuterium enrichment in 3I Atlas, 30 times higher than any solar system comet, suggests it formed in conditions far colder and far more radiation processed than any region of our own solar system. It may have formed in a dense interstellar molecular cloud, or in the outer reaches of a planetary system orbiting a much colder star, or at a time in the universe's history when the conditions for ice formation were fundamentally different. ESA's Comet Interceptor is due to launch in 2029 into a parking orbit, from where it will lie and wait for a suitable target, a pristine comet from the distant Oort cloud, or unlikely but highly appealing, an interstellar object like 3I Atlas. Unlikely but highly appealing. That phrase, from the ESA's own documentation, captures the longing that 3I Atlas has produced in the planetary science community. We had weeks to study it from a distance of 167 million miles. We had Hubble images and Webb images and X-ray observations and spectroscopy and photometry. We had more data than we got from either Oumuamua or Borisov, and it was still not enough. The answers to the most fundamental questions: what is the nucleus actually made of? What explains the 120-degree symmetric jets? What caused the mass budget discrepancy? Where exactly did it come from and how old is it? Require a spacecraft. Require flying alongside it, matching its velocity, sampling its gases, imaging its surface at the resolution that reveals geology rather than just coma brightness. 3I Atlas is gone. Past Jupiter already, as of March 2026. By the early 2030s, it will have left the planetary region of the solar system entirely. It is on a hyperbolic trajectory that will carry it back into interstellar space for another journey of indeterminate length, toward no destination we can predict, departing with questions unanswered that it had the capacity to answer if we had had a spacecraft waiting. The 22 anomalies that Loeb documented are not evidence of alien technology. The scientific consensus is clear, and the consensus is credible. They are evidence that an object from another star system is genuinely, profoundly different from anything that formed in ours. Different in chemistry, different in jet structure, different in its X-ray signature, different in ways that current models do not fully explain, and that future analysis of the data already collected will spend years working through. What 3I Atlas confirmed, definitively, is that interstellar objects pass through our solar system regularly, not once in a generation, but frequently enough that 3 have been detected since 2017 as survey telescopes have improved. The 4th is out there somewhere, approaching. The 5th, the 100. Oumuamua arrived before we fully understood what we were seeing. Borisov arrived and gave us our first clean spectroscopic view of interstellar comet chemistry. 3I Atlas arrived and gave us X-ray data, heavy water chemistry 30 times outside the solar system range, Hubble images of a symmetrically jetted nucleus, and 22 anomalies worth of genuine scientific puzzles. The next one, whenever it arrives, whatever it is, we'll find a solar system slightly more prepared. Comet Interceptor will be waiting. The Vera Rubin Observatory will be scanning the sky with unprecedented sensitivity. The community that studied 3I Atlas will have finished analyzing its data and will know what questions to ask with sharper instruments. But 3I Atlas itself is gone, receding into the dark, carrying its deuterium-rich water and its symmetrically spaced jets and its unexplained mass budget back into the interstellar medium, where it will travel for another billion years or 10 billion years past stars that have not yet formed, toward a destination that the laws of physics will determine and that no human instrument will ever observe. We saw it for 8 months. We pointed every telescope we had at it. We are still processing what we found. And the most honest summary of where that processing stands, from the scientists who did the most careful work on the most careful data, is this: it was almost certainly a comet. It was unlike any comet from our solar system. Several of its properties do not have satisfying explanations. The universe, it turns out, makes things that are stranger than we expected. And we are only at the very beginning of learning what those things are.